Okay, so good evening po sa inyong lahat. Gusto ko lang i-confirm muna kung malinaw ba yung audio natin, both dito sa Discord pati sa YouTube. So, kahit sino, ayan, nag-react na kayo sa Discord. Sa YouTube naman, paki-chat naman po if narinig niyo yung audio ko. May konting delay lang ang streaming, but okay, so good to go sa Zoom. Okay, so sa YouTube din, good to go na rin. Anyways, may konting delay lang sa YouTube, so kung wala kayo dito sa Zoom meeting, you could always join naman. Meron pa tayong 100 slots if I'm not mistaken. Okay. So anyways, hindi naman po recommended or hindi naman po kailangan na mag-attend dito sa review session natin. But of course, based on my experience, nakakatulong siya sa mga students na masagutan ng maayos yung exam. Okay, so anyways, mag-start na po tayo. Okay. So, unang-una, ang coverage po ng exam natin is going to be for those who have the module, uh, chapter 1 hanggang chapter 5. For those who don't, that would be Introduction to Biostatistics and Epidemiology, yung lesson 1 natin. Lesson 2 would be Sampling. Lesson 3 would be Data. Lesson 4 would be your Descriptive Statistics. And Lesson 5 is Statistical Hypothesis Testing. So, yun po yung magiging coverage natin and yun din po yung short review natin for today. Okay. So, simula tayo sa chapter 1 or dun sa Introduction to Biostatistics. So, kapag sinabi nating, oh, by the way, bago pala ako magsasalita dito, gusto ko lang din malaman if there are any particular areas of interest that you would like me to focus on para yun yung ifo-focus natin sa review natin. If you do so, if you have a particular area that you find difficult, paki-chat naman po doon sa chat box natin. Okay, kurtosis. Definitely. For statistical hypothesis testing, it's more of just the process of doing so. Wala naman masyadong ano doon. But yes, we'll focus more on that later. Okay, so sige. Kurtosis and statistical hypothesis testing yung medyo ano natin, areas of focus natin. But we'll begin with the introduction first. No? So biostatistics and epidemiology. This is what we know as a branch of science that aids in public health by providing actionable evidence. So, pag sinabi po nating biostatistics and epidemiology, that means that we are trying to provide evidence para maaksyonan ng ating mga public health officials or ng mga public health specialists natin. Okay? Hinahati siya sa dalawang major branch. Sorry, naka-eraser. Hinahati siya sa dalawang major branch. You have your descriptive statistics and you have your inferential statistics. Okay? So kapag sinabi nating descriptive statistics, ang aim lang po nito is to give character. So nagbibigay lang daw siya ng characteristics sa mga datasets natin para ma-compare natin yung dalawa or yung mas madami pa sa dalawa. Okay? So it gives characteristics to our datasets para mabigyan din po natin sila ng comparison. So before we can perform inferential statistics, we have to first perform descriptive. So hindi pwede tayong dumiretso sa inferential agad because we don't have the characteristics of our descriptive statistics or our dataset. So that means unlike our solid objects or actual objects, hindi natin sila pwedeng i-compare with its physical characteristics because numbers, in essence, are abstract concepts. So these are ideas that we accept na may value, and so we have to describe them further for us to be able to compare data sets. Okay? Ngayon, si descriptive statistics natin, that includes your measures of central tendency and your measures of dispersion. Okay? So, para daw ma-compare natin ang dalawang bagay or ang dalawang dataset, kailangan natin ng measures of center and measures of dispersion. And by doing so, by describing your measures of center and your dispersion, pwede tayong makagawa ng tinatawag nating bell-shaped curve. Hindi siya masyadong bell-shaped as usual. So, ang tagal-tagal ko nang ginagawa to pero I could not for the life of me create a perfect bell-shaped curve. So, anyways, dinedescribe itong bell-shaped curve na to, otherwise known as your Gaussian curve, sometimes referred to as your normal distribution curve, sometimes referred to as your bell curve, simply. Okay? But itong bell-shaped curve na po natin ito, itong characteristics niya, yung pagkataas, yung taas, yung lawak, or yung spread niya, is described by 4 different values. Yun yung tinatawag nating moments ng statistics. So the first moment would be your mean, which is at the center, describes the center of your data. So this is your first. And then your second moment is your variance, which describes, well, the spread. So variance is your second. Your third describes its skew or its symmetry. So that would be your skewness. Okay? Yung pagka-symmetrical ng ating curve. That is your third moment of statistics. And then yung fourth naman natin describes its height, otherwise known as your kurtosis. So this is your fourth moment. Kapag sinabi nating height, we also refer to its tailedness. So sa quiz natin, dyan maraming nagkamali or dyan maraming na-confuse. Kasi iniisip nila, yung skew describes the tailedness because syempre nga naman, mas mahaba yung tail sa kabila or mas maliit yung tail sa kabila. But in actuality, when you want to describe the tailedness of a curve or a certain dataset, kailangan may kurtosis tayo. Okay? Because platykurtics, or pag sinabi nating platykurtic, ayan. Pagbigyan nyo na yung drawing. Medyo na-disappoint din ako, pero pagbigyan nyo na siya. Leptokurtic daw po siya. So, kapag leptokurtic siya, of course, mataas yung peak natin. That also means na hinihila ng peak or nung natin, pataas yung tails ng ating bell-shaped curve. So, kaya siya nagmumukhang telang hinila. No? Mukha lang siyang telang hinila sa sa drawing ko. Pero isipin niyo na lang na kapag tumaas, syempre yung peak ng ating data, umiiksi din yung tails niya. And of course, kapag mababa yung peak ng data natin, that means also mahaba yung tails niya. Okay? So, tailedness, kurtosis ang ating descriptor. So, again, just to review, yung mean natin ang nagde-describe ng ating first moment, yung center. Second moment naman yung nagde-describe ng spread ng data natin, which is the variance. And then, third moment describes the symmetry of our curve. And then the fourth moment describes your kurtosis or your tailedness. Okay? So, itong apat na moments na to or yung characteristics na to or descriptives na to is very important in providing descriptions that can be compared through inferential statistics. So, bago natin ma-process ang ating inferential statistics, at least we have the first and the second moment, yung mean and yung variance. Okay? Kurtosis and your skew, typically ang binibigay lang niya sa atin is the idea of what tests we could use and what tests we could not. Pero hindi naman kasi sensitive yung mga statistical models natin dito sa dalawang 'to. So we don't necessarily take much mind to the kurtosis and skewness when we perform inferential statistics. Okay? So, okay. Now, once na-describe na natin yung dataset natin, we move on. Masi-save, sorry may nagtanong lang 'no, masi-save po ito sa YouTube if I'm not mistaken 'no. Automatically after the stream it is uploaded to YouTube. I'm not sure though kung ganun pa rin yung Zoom. Anyways, okay. So back to the lesson or back to the review. Kapag tayo ay nakapag-describe na ng dataset natin, pwede na tayo mag-proceed sa inferential statistics. So again, si inferential statistics naman, ang purpose niya sa buhay ay pagkumparahin ang dalawang bagay or ang dalawang dataset. So we want to compare or we want to relate two datasets. And tandaan po natin, ang acronym natin is just RED. Okay? Relationship, effect, and difference. Okay? So ito po ang ano natin. Tatandaan nyo lang. No? So for inferential statistics, what we're trying to look for is first and foremost relationship. Next is effect. And lastly is difference. So kapag sinabi daw nating relationship, itong variables A and B ay nakakaapekto sa isa't isa. So for example, tumaas daw si A, tataas din si B. Okay? Kapag naman effect, walang epekto ang isang variable natin dun sa kabila. So for example, si A, nakakaapekto siya kay B, pero si B, hindi siya nakakaapekto kay A. So no effect daw si B kay A. So pag tumaas si A, pwedeng tumaas din si B or bumaba, but kapag tumaas or kapag may changes kay B, walang pakialam si A. Okay? So ganun yung nature ng effect na hinahanap natin. Kapag difference naman, difference is, well, difference. No? Pinagko-compare natin silang dalawa. Okay? What you need to know about difference is that it could be through multiple groups, independent, or through paired groups na tinatawag natin. So pag nag-compare tayo ng dalawang variable, we could either see or check if one is greater than the other or one is less than the other. Okay, so these are the differences that we typically encounter. Okay? So ayun po ang introduction natin to biostatistics. Excuse me. Biostatistics and epidemiology, no? You need to know the two branches and what it does sa ating data. Okay. So far, nakakasunod naman po lahat. Now, this is just a review session so medyo mabilis po yung ano natin, yung phase natin. Okay, so next concern po natin or next topic natin is sampling. Now, for sampling, meron tayong dalawang major techniques na ginagamit. Yung tinatawag nating probability and yung non-probability sampling techniques natin. So, kapag sinabi nating probability, we are referring to the chance of a certain member of the population to be selected as a sample. So, kapag sinabi nating probability sampling, everyone has an equal chance to be selected. Kaya siya tinawag na probability because everyone has the same probability. Kapag non-probability sampling naman, they don't have an equal chance. May advantage yung ibang tao. Either by proximity, yung lapit nila sa research, or by simply purpose. Okay? So, yun po yung difference ng dalawa. No? Probability sampling is equal chance for everyone. Non-probability, may advantages yung iba. Okay? So, that's the difference between the two. Now, for probability sampling natin, we include your simple random sampling. We include your systematic sampling. Kasama din ng stratified. And of course, yung cluster sampling natin. Now, kapag sinabi po nating simple random sampling, this is also referred to as your fishbowl sampling. And this is also considered or widely considered to be the best technique para maka-obtain ng representative sample. Okay? Okay? So, uh, again, yung simple random sampling natin is the best sampling technique to obtain a representative sample. And at the same time, ito rin po ay tinatawag nating fishbowl sampling or lottery sampling. Okay? Kapag naman systematic, first we set a certain number of representatives, number of samples, then nagse-select tayo or gumagawa tayo ng system to select the next. So for example, yung first sample natin is going to be selected through a dice roll, and then the subsequent samples will be selected by a set rule. For example, another dice roll ulit. And then every third sample ang kukunin natin. So if you have 10 samples, for example, meron tayong 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you're going to select every third sample. So 1, 2, 3. Okay. This system is entirely up to you. Kayo po ang bahala dyan kung paano nyo isa-set yung system nyo, as long as you set it with some level of randomization. No, so hindi pwede nating piliin. So for example, nakita niyo yung kaibigan niyo nasa second line or nasa second number. So hindi niyo pwede siyang piliin. Okay? You have to introduce some sort of randomness doon sa selection natin. Okay? And then stratified sampling naman, dinidivide natin yung population natin into what we call strata or groups. No? So, dinidivide natin sila into much more manageable groups. For example, meron tayong 500 na members ng population. I-divide natin siya into 200 and 300. And then, kukuha tayo ng sample dito sa ating 200 and 300 proportional to its sample size. So, kung natatandaan niyo po yung formula natin for proportional sampling, that would be N1 or N2 kung dalawa po. N1 hanggang N2 kung dalawa po yung sample natin or dalawang grupo yung samples natin is equal to your sample size divided by your total population times the population of your first group. So in this case, ito yung magiging group 1 natin and then ito yung magiging group 2. Okay. So, oh my God. Di pala siya naka-unlimited meeting for more than 100 participants. So anyway, sige, mag-reconnect na lang tayo. Anyways, yun lang po yung ano natin for introduction to sampling. Cluster naman, instead of selecting particular or members from each group, ang ginagawa po natin dito is we're selecting the whole group itself as the sample. Okay? So unlike your stratified sampling, for example, yung 500 daw natin ay dinivide natin into smaller groups. Let's say 200 or 500. Sobra yung 500. 300. Ang isineselect po natin dito ay yung isang grupo mismo. So we're not taking samples from each group but we're taking the actual group as the sample. Okay? So yun yung pinagkaiba nilang dalawa. For cluster sampling, you take the samples or the clusters as the samples. For stratified naman, yung groupings natin ay groupings lang talaga. And then kumukuha tayo ng proportional samples from each of these strata. Okay? So anyways, sa cluster sampling natin, yun lang. Next, for non-probability sampling techniques naman natin, non-pro, you have your judgmental or your purposive. You also have your convenience. You have snowball. And you have your quota sampling. Okay. So for judgmental or purposive, meron tayong set characteristic na hinahanap sa population. Ang lagi kong ine-example dyan is, for example, may diabetic na patient, then lahat ng diabetics lang ang pwede nating i-consider as our sample. Kapag naman convenience, simple lang kung sino yung malapit, kung sino yung pinaka-convenient na sample. Kapag snowball naman, this one is typically used for sensitive cases. Okay? So ginagamit natin siya for cases that we want to keep discreet. Like for example, extramarital affairs, HIV, or yung mga STIs natin. So ito po yung snowball sampling yung ginagamit natin because we can't overtly hindi naman tayo pwedeng mag-announce sa isang assembly or sa isang class, "Oh, sino dito may HIV? Taas ang kamay." Siyempre hindi because we have to protect the privacy of those persons living with HIV. So instead, hahanap tayo ng isang tao na afflicted with HIV or living with HIV, and then siya yung aasahan natin na magdala ng additional sample sa atin. Okay? Next, for quota sampling. For quota sampling, meron tayong set number of respondents sa kada characteristic. Like for example, kailangan daw natin ng 30 males and 30 females. Okay, pwede din nating i-subdivide further yung 30 males natin. Kailangan may 10 na nasa age group ng, let's say, 10 to 17. Kailangan daw may 10 na 18 to 26. And then meron din 10 na 27 to 35. Okay. So, pwede nating i-subdivide yung requirements natin depending on what we need. Depende sa pangangailangan natin. So, yun yung quota sampling. Kaya siya tinawag na quotas because we have to meet a certain quota para doon sa ating samples. No? Okay? So, any questions so far? So far po ba nakakasunod kayo? Okay. So, I'll stop here for a moment. I-end ko lang muna yung meeting kasi hindi pala niya kayang i-accommodate yung unlimited minutes sa meeting na more than 100 participants. Later yung experimental pag reconnect natin. Okay. So for cluster sampling, hindi lang po one group ang isa-select natin, no? Depende po dun sa required sample natin. Kung ano yung papasok na grupo. Usually for cluster sampling, no? Let's say meron tayong 1,500 na participants or population. Di-divide natin yan into groups A, B, and C. Tapos kailangan daw natin ng 700. So, we're going to perform random sampling dun sa groups A, B, C natin to select kung sino dun sa grupo na yon yung makakasama sa cluster natin. Okay? For sample size naman po ng quota sampling, wala naman po tayong set na wala tayong set na sample size for quota. Typically kasi for quota sampling, ang nagsaset po niyan ay depende sa pangangailangan. So for example, kailangan ko ng isang daang katao. Then yun yung isa-set ko na sample size. Okay? Again, the reason why we select or get a representative sample is because we want to generalize our study. Ngayon, yung non-probability sampling techniques natin is not typically something that we use when we want to generalize our study. So hindi tayo naghahanap ng generalization that applies to everyone but rather applies to what we need at the moment. So hindi natin kailangan actually mag-perform ng sampling kapag non-probability sampling techniques ang gagamitin natin. Usually, tayo po yung nagsaset ng sample size natin kapag non-probability ang gagamitin. Okay? So, sige, paulit po ng systematic sampling natin pag reconnect. Parang hindi naman siya nag-e-end. Naka 10 minutes na. May 3 minutes pa daw. Okay. So anyway, sige, i-end muna natin yung meeting. Tapos, we'll reconnect and then tuloy natin yung review session natin. Okay?